Hi, welcome to video 4 of day 1. In the previous video, we talked about how Java is a secured language. So in that we have seen if you have created a program using C, C++ and compiled it, you get an executable which directly runs on the operating system. Hence has the open access to all your files, folders, everything, and it can be malicious. Yeah. Whereas in case of Java, what happens? Your Java programs are expected to run within JRE, a secured environment. They don't have access to outside world, such as your files, folders, etc. They can't directly talk to operating system, etc. So because of that, you have your Java program running within a secured environment. Hence, Java program can't do anything mischievous to outside world. So your system is safe in running the Java program. So that's how the security is attained or security is maintained. Yeah. Now let's get into the next feature of Java, which is platform independent. So how Java programs can be platform independent? Yeah. So again, going back to the same concept, we know that Java programs are expected to run within JRE, Java Runtime Environment, right? So any Java program you write, okay, that has to run within JRE. Now that JRE has to talk to operating system. So the operating system could be, for example, your Windows. Yeah. So or your friend may have the operating system which is, let's say, Linux, and your third friend may have an operating system which is, let's say, Mac. So basically, your JRE has to work with any of these operating system, but your Java programs have to work with only JRE. So that means your Java programs only interact with JRE, and JRE in turn interact with the operating system, and then the operating system in turn interact with hardware. So because of this, what happens now is whatever the differences you see here in the real world, like your friend has Linux, you have Windows, or you have Mac and your friend has Windows. Whereas in hardware also, like there could be 32-bit processor, there could be 64-bit processor, etc. Right? Different hardware, different operating system. But that particular difference is isolated by JRE. So what it means is JRE is dependent on operating system. So you are going to install JRE on your machine. If you have Windows, then you're going to install JRE which is meant for Windows. Yeah. And if you have Linux, for example, then you're going to install JRE for Linux. And similarly, your friend is going to install JRE for Mac. Yeah. So JRE is platform dependent, remember. But then once JRE is installed, right, then Java programs have to work with only JRE. So because of that, Java programs don't know whether they are running on Windows or whether they are executing on Linux because JRE is shielding it. Yeah. So because of that, Java programs get platform independent. They need not worry about what platform they are running, what OS they are running, what hardware they are running. Yeah. Similarly, they need not worry about the architecture also. So if I take the architecture part of it, some systems come with 32-bit architecture, some with 64-bit architecture, some with like for example a completely mobile-oriented architecture, etc. So your program need not worry about what OS, what hardware, what architecture, etc. It is only worried about how to execute within JRE. That's it. And because of that, you gain the platform independence and architecture neutrality. Yeah, that are the two strong features. Because of that, Java has become so popular. Yeah. Now I'll take the same thing, continue with portability also. Now what happens is Java has a slogan like you write only once and you can execute or run any number of times. Okay, so you need not worry about, for example, writing a program for Windows. Okay, and similarly writing the same program for Linux. You need not worry about it because your program, Java program, is actually not worried about the platform at all. It is only worried about JRE and execute inside the JRE, right? So because of that, what happens is I can write the program and I can actually, for example, when we actually start writing the program, we'll normally write Java programs as .java files, yeah. and then we do something called compilation, and after compilation we get something called bytecode. Okay, I'll explain this in detail. Yeah, we will get an intermediate output. Like as I said, you are writing programs using high level programming language, whereas machines only understand binaries, zeros and ones. So your high level program has to be compiled or has to be translated to binary language, right? So one of that translation process, we call it as compilation. I'll explain about compilation in detail, but for now just imagine your Java program once compiled will become bytecode, which is in general we normally call it as dot class file. Okay, so it's something like an intermediary product. Yeah, so once I have this bytecode, right, I can give it to anyone. Okay, anyone who has JRE. So if your friend has JRE on Windows, yeah, or if your another friend has JRE on, let's say, Linux. Yeah, so now both of them can take this bytecode or compiled version of your Java program, or in general in normal world we'll say give the Java class file. Yeah, so it's a bytecode. So using that bytecode they can actually run it inside their own JRE. They need not worry about Linux or Windows machine. So when I am writing this program, I am not worried about whether it is going to be executed on Windows or Linux or Mac or any other architecture, right? So I'm only writing the program for Java specification, and then everything else is taken care by the platform. How to convert it into bytecode and then how to execute it within different environments is taken care by the Java runtime environment. That's why your Java programs are portable. Portable in the sense I can write it for Windows and then I can easily execute it on Linux. Whereas in case of C, C++, for example, if I take C, C++ example, what happens is if you compile it on Windows, a C program, if you compile it on Windows, you get .exe file, yeah, which only can be understood by Windows based systems. Yeah, if the same program C, C++, okay, compiled on Linux machine, you get some version of binary. For example, you might have seen we get something called a.out. If I'm not renaming the output, it normally comes as a.out, an executable file. But again, this binary is only understood by Linux kernel. Yeah, so what it means is it's the same source code. Yeah, but then when I'm actually compiling it for one system, I get an output which is executable for that system, that environment. Yeah, whereas if I compile it on another machine which is Linux, I will get an output which is compatible to that environment. I cannot take a compiled version of binary and try to execute it on Windows system here. Yeah, so they are not portable enough. You have to do one extra step, that is compilation on a specific machine. Here we don't do that. So in Java, once you compile, the bytecode is only meant for JRE. It is not meant for Windows or Linux or anything. So that's why it is portable. Yeah. So we'll see other features in the next video.